Hello everyone. In this part of lecture, I am going to discuss one more numerical based on the transformer. So transformer, this problem solution. So let us see. An ideal transformer has turn ratio, means N1 by N2 is given as 100 divided by 300, means 1 by 3. Ideal transformer is ideal, means ki there is no winding resistance, there is no flux going in the air, means whatever flux is coming, it is going to the only core. Here this is the core and flux is going in this direction only. There is no flux going into the air, so all flux coming is going into the, this is the core and going into the core of the transformer. This is primary side, means here number of turn is 100 and here number of turn is 300. Now in it is an impedance of and low voltage winding. So 100 turn means this is low voltage winding. Here 3.3 kilovolt, volt 50 hertz. An impedance of 100 plus j. This side an impedance is connected in the load side, which is equal to 100 plus j 35. So this impedance is connected across the secondary terminal. Calculate the maximum value of core flux, the primary and secondary current, the real and reactive power supplied by the source to the transformer primary, the value of impedance which connected directly across the source would draw the same real and reactive power as in part C. Means these four part we have to solve, and all parts carries very interesting informations. So let us see how we can solve this problem very easily. So our first part is to find the maximum, calculate the maximum core flux. So we need to use this E1 equal to 4.445 number of turn N1 into frequency. So this relation is already explained in my previous lectures. I will share its link to this video also. So E1 is how much? Here 3.3 kilovolt, 3.3 into 1000 equal to 4.44 into flux. This we have to calculate. This is called phi max. This is called phi max into number of turn in primary side is 100 into frequency is 50. So after solving this, we will get phi max, which is equal to how much? You can solve and you can check. It is coming 0.149 Weber. 0.149 Weber. So part 1 is solved. Now we go for the part number 2. This is part 1 is over. So let us see part B. Part B is saying that, what is the part B? Part B is to the primary and secondary current. Primary and secondary current we have to calculate. So here see, secondary impedance is given. Secondary impedance is given. Secondary impedance is this much. This is the secondary impedance. And secondary voltage we have to calculate for the, so V1 by V2 equal to N1 by N2. Here V1 is how much? 3.3 and V2 is unknown and N1 is 100 or N2 is 300. So after solving this relation, we will get V2 equal to 9.9 kilovolt. V2 is now known. So secondary current I2 will be equal to Ohm's law, V2 by Z2, and V2 is 9.9 kilovolt divided by Z2 is 100 plus J35. Here a very interesting thing is given in this question is that you can see here I2. So here I2 will be equal to 9,900 divided by this magnitude will be equal to 100 square plus 35 square under root, and there will be angle also that is equal to tan inverse 35 divided by 100, coefficient of j. This portion is outside from the square root. This is not inside. This portion is, I'm putting different color. This point is, this whole thing is outside from the square root. Square root is only this. So impedance, you see here, the impedance has 100 plus j35. Plus j35, what does it mean? Plus indicates that our load is inductive. This is load is inductive, not only resistive, it is inductive. Plus j. If minus j is there, then load will be capacitive. And for inductive load, what will be the current? Current will be lagging. Current will be lagging. This is very important thing. Current will be lagging for inductive load, and for capacitive load, current is leading. So after solving this relation, we will get, you solve it, use the calculator, you will solve it, and you will find that it is coming 93.44. Its value is coming 93.44, and angle, it is in denominator, so this is coming 19.3. so if it goes upside, we bring it upside, it will be 19.3 degree. So I2 current will be this much, its magnitude is 99.44, but lagging with respect to voltage by 19.3 degree. Negative angle means lagging. Now we have to find out the value of the primary current also. So use this relation, I1 by I2 equal to N2 by N1, and N2 is given in this problem 300 and N1 is given as 100. Am I right? Yes. And N2 is given 300, and I1 we have to calculate. Here I2 we have already solved. So I1 by I2 equal to N2 by N1. So now we need to put the value of N1, N2 and the value of I2. So I1 will be equal to, from here we can write I1 will be equal to I2 multiplied by 3. This portion is going out. So we can solve this. I2 already we have calculated 99.44 angle minus 19.3 multiplied by 3. So it will be, just solve it and you will get its value is 280.3, approximately 280.3, and angle is minus 19.3. This is the primary current. This value is coming like this. So primary current, secondary current is all known. Now very interesting part is coming to the part C. Part C, the real and reactive power. So real and reactive power, part C, if we go for a real power, what is the real power? That is P equal to VI cos theta. So for primary V1, I1 cos theta, because the angle both side, primary side or secondary side, both side is same. Here primary angle is minus 19.3 and secondary angle is also, I2 current is also this much same angle. So here we can put the primary voltage, which is equal to 3.3 kilovolt. Primary voltage is, or LV side voltage is 3.3. So here it is 3.3 kilovolt. So you have to multiply it by 1000. And I1 is how much? I1 just calculated 280.3 cos. And this angle is the between voltage, theta is the angle between voltage and current. So we need to put 19.3, and we, after solving this, we will get the value of real power, which is coming 873, approximately 873.1 kilowatt. So real power is known. This is also equal to P2. You can check it, P2, which is equal to V2 I2 into cos theta 2. Cos theta 2 is again this much. This is 19.3. V2 is 9.9 kilovolt, and I2 is already this. You have to put this. You can verify. This value will be also same. Now real power is calculated. Now reactive power. Reactive power, which is called Q, it will be equal to V1 I1 sine theta 1. So putting the value V1 is 3.3 into 1000 into I1 is this much, 280.3, and sine angle between voltage and current. So taking it 9, just take its magnitude. So this value will be magnitude of reactive power, and it is coming 305.7 kilo, 305.7 kilovolt ampere reactive. Its unit is kVAR, kilovolt ampere reactive. So P and Q, and this value is also equal to this is Q1, so it will be also equal to Q2. You can check it, which is equal to V2 I2 sine theta 2. Theta 1 and theta 2 both are minus 19.3. Now coming to the part D. The D part is asking the value of impedance which connected directly across the source would draw the same real and reactive part. I see. Means ki how much impedance we can, if you see this transformer circuit, we can see. So in question, it is asking that here impedance we have already connected Z2. Z2 as our impedance. So in question, it is asking how much we connect this side, source side impedance, so that same amount of real and reactive power is used. So means we have to just convert this Z2 into the primary side. So Z2 dash, which is called secondary impedance, referred to primary side. Secondary impedance seen from primary. Seen from primary. How much it will be? It will be equal to A square into Z2, and A square is how much? A is the number of term on primary divided by secondary whole square into Z2 is 100 plus J35. Just solve it and we will get its value, which is equal to 11.11 plus, this is coming 11.11 plus J, how much? 3.89. 3.89. It means if we connect this much of impedance in the primary side, this real and reactive power would be the same. Okay, thank you very much for watching this video.